Welcome back. We are going through section 1.5, subsection 2, character counting. This is from the K&R C programming language book. Here we go. So the next program counts characters. It is similar to the copy program from the previous section. So let's jump in to writing some code, example 0.c, and we will first make our include statement. They're going to use standard IO in this example. That's fine. We'll put int main for our main function. And now we'll start defining what they say they want to define here. So one is going to be a long type called NC. Maybe not the best name in the world for descriptiveness, but we'll follow along. And NC is going to be initialized to a value of 0. Now we'll enter a while loop. We have our expression for where we'll continue on with this while loop. And we want to call getChar and check does it not equal end of file character. And in this loop, we'll then say ++nc. And, depending on what we want to do here, with maybe the printf statement, we'll actually put it on the outside here. So we'll have %1d for one position of this precision NC. And we're just doing basically a formatted print. Great, so then if we compile this, example C, just call that example 0, we are getting a little bit of a complaint here about, from the compiler, warning, %d expects arguments to be of type int, but argument has type long int. And so there's this W format thing. I don't think we'll fix that at the moment, but that's probably some later development. We know that we've written out more or less the right code here. So let's continue. So it doesn't actually show anything immediately, but if I start going ASDF, now I don't see this showing to the screen. Instead, let's tuck this inside of here, and maybe we'll get like a count when we run this. There we go. So now it's going to count basically the length of our input this time. Not just 42. I think this is going to be an accumulating a cumulative count, right? So if I put in, 5 at a time or something, it's going to go up by 5. Okay, so that is an example of counting the number of characters. As we get each character, we basically increment. Easy peasy. So let's read what they have to say here. The statement, ++nc, presents a new operator, that is ++, which means increment by 1. You could instead write nc is bound to the value of nc plus 1, but ++nc is more concise and often more efficient. I don't know if I've ever timed that, but it could be true. There is a corresponding operator, minus to decrement by 1. The operators ++ and minus can be either prefix operators like ++nc or postfix operators nc++. These two forms have different values in expressions, as will be shown in chapter 2. Okay, we won't worry about that, but we should know that that's a thing. But ++nc and nc++ both increment nc. For the moment, we will stick to the prefix form. Fair enough. So the character counting program accumulates its count in a long variable instead of an integer. Long integers are at least 32 bits, although on some machines int and long are the same size. On others, an int is 16 bits with a maximum of 32,767, and it would take relatively little input to overflow an int counter. It's good to know that there are these differences to watch out for. Of course, this is also a potential source of confusion of like, are these things the same? Are they different? So I suppose that's probably what I'm running into with that warning from the compiler, is that I have mixed the types as far as the compiler is concerned. Now, the conversion specification of %1d tells printf that the corresponding argument is a long integer. Okay, It may be possible to cope with even bigger numbers by using a double, that is, double precision float. We will use a for statement instead of a while to illustrate another way to write the loop. Sure, there are a bunch of situations in which for loops and while loops are interchangeable. Now let's call this example 1. And verbatim here will include standard IO, our main function. Of course, is going to return int here, and instead of int or long, I should say, we'll put in double. And now we'll have for nc get char does not equal end of file, and then our increment step. Kind of a strange syntax, I'll admit. I personally like the curly brackets around these, but it is sometimes used in C and maybe C++ to have these kind of one-liner for statements. Anyway, so here we're going %.0f for float, for our double float, nc, and we will compile this. Example 1. We put on the right flag there for output. And we have example 1. And I think here we're running into the same kind of issue that we're not seeing. That's the binary. The output. I would personally rather just stick this in the for loop for clarity. And what it's going to do in this implementation change is it's going to show every iteration of the loop. So there's my count. It is 0 based, so I should probably consider modifying that, but nonetheless. So that's an example of a simple kind of counter based on getting the characters from the standard input. Now printf in this case uses %f for both float and double. A percent of, I'm getting a little bit wild with the highlighting here. I don't care about that. Suppresses the printing of the decimal point and the fraction part, which is 0. The body for this for loop is empty because all the work is done in the test and increment parts. But the grammatical rules of C require that a for statement have a body. The isolated semicolon is called a null statement. It is there to satisfy the requirement. Yeah, it's like a weird technical gotcha of the syntax. I have to admit that among the ways that I expect to see a for loop in a programming language, I'm not, even though it's valid syntax, I'm not that happy to see like these null statements. Maybe I'll get used to them. Maybe. All right, so before we leave the character counting program, observe that if the input contains no characters, the while or for test fails on the very first call of the get char, and the program produces 0, the right answer. This is important. One of the things about while and for is that they test at the top of the loop before proceeding with the body. If there is nothing to do, nothing is done, even if that means never going into the loop body. I think that's perfectly fine. Programs should act intelligently when given 0 length input, and the while and for statements help ensure that programs do reasonable things with boundary conditions. So that was a very short little section we went through, but it shows a simple enough example of basically having a counter, and when there's standard input that's a sequence of characters, you can count them up until you get to the end. I'm not quite sure. I have to maybe look into why am I not getting, like, not just any output. Oh, actually, here we go. That's fine. Okay, so when I pressed enter, I get the EOF. Mystery solved. Anyway, nice short example. And, I don't know what else to say about counting other than it's great. It's been around since the ancients, and that you can do this with either while loops or for loops. So hopefully that's interesting or useful to you, and I'll catch you in the next one.